To just go through 8.6 notes, and I apologize for not doing some of these last week. As you can imagine, it was a little hectic. All your teachers were trying to find the best way to put their classes online and still have you guys learning. So thank you for bearing with us. If you have any suggestions, please let us know. So when we're talking about identifying special quadrilaterals, and this is where that diagram that you guys made comes in handy. When we're talking about identifying quadrilaterals, well, we know quadrilaterals have four sides. So if it doesn't have four sides, it's automatically not a quadrilateral, and it can't be any one of our special quadrilaterals. But if we're looking at a quadrilateral ABC, has both pairs of opposite sides congruent, what types of quadrilaterals meet this condition? Both pairs of opposite sides are congruent. There's many possibilities. So our opposite sides here are congruent in a parallelogram, in a rectangle, but in a rhombus and square, all of our sides are congruent. That means our opposite sides are as well. So this quadrilateral ABCD could be anything, but a parallelogram, rectangle, rhombus, or square, any of those four. If you see my note over here, it says you can only use what info you know that's given, okay? The info that you know that's given info, okay? What is marked, or what does the problem tell us? So if we're looking down here at example 2, what's the most specific name for the quadrilateral ABCD? Now looking at that, you're going to automatically want to call it a square, right? It looks like a square. You're going to say, Miss Irons, that's a square. Guess what? No, it's not. You cannot tell me that it's a square, because all I know about this shape right here, I know that my opposite sides are congruent and all four sides are congruent. So in a parallelogram, we know opposite sides are congruent, so we know it's a parallelogram. Now, if every single side is congruent, that's a property of a rhombus. We don't know anything about the angles, okay? We know squares are rhombi, okay? Squares are also rhombuses. However, there's no information given about the angle measures, so we cannot say that this is a square. All that we can say is that this is a rhombus. We can only use what is given to us. So if we're looking down here, identifying the quadrilateral, is there enough information given in the diagram to show that this is an isosceles trapezoid? Yes or no? Well, first we need to show that this is a trapezoid. Okay, G and H are supplementary angles. Thus, F and G and GH are parallel. These two lines here are parallel because of the alternate interior angle. Same side interior angles, consecutive angle theorem. Okay, FJ is not parallel to GH. Why? Because we see that this is 102 and that's 102. So if we're looking at FG and GH, those are not parallel, but FG and JH are. Okay, thus by definition, this is a trapezoid. Now, how do we show that it's an isosceles trapezoid? Well, in an isosceles trapezoid, F and G are a pair of congruent base angles. F and G, congruent base angles. That means J and H are also congruent base angles. Thus, by theorem 8.15, which I would rather you just know that property, which in an isosceles trapezoid, both pairs of base angles are congruent. Thus, that is a isosceles trapezoid. Reading through these other two checkpoints. So, number 2, what is the most specific name for a quadrilateral QRST, and explain our reasoning? We can only call that a kite. We have two pairs of consecutive congruent sides. That's one of our properties of a kite, so we can call it a kite. Nothing much more there. Looking at number 3, is there enough information given in the diagram to show that the quadrilateral is a rectangle? Now you're going to look at me and say, Miss Irons, that's a rectangle. Yes, but you have to prove it. So we know that measurement of angle D is going to be 90 degrees because a quadrilateral adds to 360, and if we already have 3 that are 90, that means that fourth one's going to be 90. Both pairs of opposite angles are congruent, so it's a parallelogram. And because it's a parallelogram and all 4 angles are 90 degrees, it is a rectangle. So just kind of looking through those. That was kind of short notes for today. So if you have any questions, reach out to me, but make sure you get your activities done. So if we're looking back, is this you guys? Yep. Make sure that you complete that Desmos activity and the quizzes activity. Bye.